You and my father.
Great minds. So we have two things left to accomplish, and then I'll give you a practice quiz. So I have a feeling it'll be like today, tomorrow, practice quiz Wednesday, go over practice quiz probably Monday or so. Today we're going to find terms in a sequence when we're given the recursive formula and not the explicit. So if like I said, I wanted to do this last week, and this can get a little bit harder. I'm going to leave that part out today, but we're going to kind of do the the more normal version of this, and then I might put some more tricky ones somewhere down the line, especially maybe like for extra credit on the quiz or something like that. So to be clear, don't write this part down, okay? Because I just think I don't want it to get muddled with, if I gave you this, um, like this, um, this is an explicit formula. And I know that that's one of the hardest things for us to get our heads around is what an explicit formula means. So this is the kind of formula where if I said to you right now, find the 153rd term. The goal is, can you interpret what this means? Can anyone tell me right now what the first term of the sequence would be? And please don't give me an answer until I'm ready. I don't want to hear it. What is it? Good. So if I said, I want to know what the sequence looks like, it starts with the number 13. And what does it go up by each time? Yeah. So this is just a classic, basic arithmetic explicit formula. And it just says to go up by 3. So your options at this point are, if I said, I don't even remember what I said, like the 154th term, is that what I said? Something like that. I mean, option 1 is to grind it out and actually go and write out the first 155th. But the beauty of an explicit formula like this is that I can go right in and I can actually just change the letter N into 154. So like if you had a calculator out just now, rather than going through and writing out all 154 terms, you could just go in and just put a 154 right there. And if you do that, then what you type into your calculator is actually 13 plus 153 times 3. Right?
Yeah,
I don't know what's going on. Will you hang on a second? I need to pause this real quick so I don't. We're back. So that's how you use an explicit formula, okay? It's very to the point, and I'm sorry if you're struggling with that, but like that's as easy as math gets. If I say find the whatever, you just put that number in for n, type boop, 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 and you get the answer. Like it's one-stop shopping. So we're going to take a different approach today, and it's not really all that difficult. It's sort of the idea, though, is based on, do you understand how a recursive formula works? And so let's put a so this is now today's notes, right? So let's say I gave you a recursive formula like this. It's really hard. This is why I figure there's 4 things that you have to learn. There's recursive arithmetic, recursive geometric, explicit arithmetic, explicit geometric. By taking the geometric out of it for the next few days, at least we can just focus on 2 things: explicit, recursive, all plus and minus sequences, okay? So no geometrics. You won't see any geometrics in here until probably Thursday or Monday or something like that, at least. So do you guys interpret this formula correctly? Like, what does it mean? Can you tell me where the sequence starts? Well, yeah, it literally says a sub 1 equals 12. So part of the recursive formula, remember, is that you'll be given the first term. That's a thing. I Googled it today and everyone agrees. Like math teachers Google math stuff too. And I just thought, is it really standard practice? And it is. So like, because I wondered if like, can I still count it as a recursive formula if I don't give you the first term? And the consensus I got from the internet was pretty much no. So you'll always be given the first term. That's great. And can you tell me how the sequence behaves as I go from one number to the next to the next? It's going down by 5, right? Like that's literally what the sequence describes. It is, remember this number over here for your notes, you may want to refer, we've already taken notes on recursive formulas, by the way, but this number is like the behavior number. He's the number that tells us how does the sequence behave. If there had been a +6 there, then I'd know that this sequence is going up by 6 each time, right? The math is not hard. It's the language barrier issue of like all these stupid n's and n-1s and stuff. It can be confusing. So now that we understand how this works, we could start writing out the terms of the sequence. If the first term is 12 and the behavior of the sequence is -5, what's the next term? It is. Take away 5, you get 7. Take away 5 more, what do you get? 2. Take away 5 more, what do you get? Go again. Go again. Okay, we're done. Now, that's all fine and good. And this goes back to something that I said before. If I ask you for the fifth or sixth or seventh or eighth term, you're like, that's no problem at all. Like, if you want the sixth term, I've already got it for you right there. It's -13. You want the eighth term? Oh, I'll just go a couple more. Where it becomes interesting, and this is really the meat and potatoes of today's lesson, is what if I ask you to find the 459th term? Right? I don't know about you, but I don't want to write out the first 459 terms. Like, ain't nobody got time for that. I think I'd rather take a 0 on that problem on the quiz than write this all out. Hence the shortcut method that we want to talk about today. And it's not bad. It's interesting that it sort of ties into an explicit sort of formula idea, which may or may not make any sense even after this lesson is over. So let's talk about this. So if you've fallen asleep or are distracted by something, now's a good time to have some sincere focus on the lesson. This sequence starts at the number 12, and every time I move one space to the right, what do? I subtract by 5. Now, here comes the big question. And this is really what will determine whether or not you understand this and are ready to rock and roll. This is a sub 1, right? This is the first term. Somewhere over here is the 459th term, aka a sub 459. Like, those mean the same thing, right? My question to you is, this has come up before. How many jumps would I have to, how many moves on the board would I have to make to get to the 459th term? Correct. We've been down that road before, haven't we? Yeah. We've talked about that. Like, wherever I want to get to, I just have to go like take that like -1, right? So you want to get to the 10th space, move 9 times. You want to get to the 1000th space, move 999 times. So since we want to get to the 459th, we're going to make 458 movements. And how much is each movement going to be worth? -5. So the math that I'm going to type into my calculator looks like this. And it is just an explicit situation. It's very interesting how it all comes together. I'm going to take the number 12 and I'm going to add 458 multiplications or instances of what number? Correct. -2,278. The goal for the day is, can I find numbers that, I mean, could you find that old school? Yes, you could. And like on today's worksheet, if it says find a sub 34, could you go and actually manually find the 34th term? Yes, you could. I don't want you doing that, though. I want you using the logic of number of jumps times the value of each jump. Presto. Let's practice again. Easy? Okay. So the key is, I'm not going to give you any explicit formulas. I'm only going to give you recursive today. So here's a recursive formula. Any term is equal to his predecessor increased by 11. Now, the reason why that formula right now is no good is because you're like, well, I have to have like a starting point. Hence the a sub 1. And let's say that a sub 1 is -52. It's important to me that the language for you is starting to fit. So someone just in plain English describe this sequence to me. What is it like? What does it mean? Where does it start? And what does it do? You got it. And so if someone said, hey, write for me the first couple few terms, I'd be like, okay, I got the language. First term is right here. So I'm going to begin writing your stupid sequence at -52. Now, the number at the back, remember, is the behavior number. He says to add 11. So what would the next couple of numbers be? If I go up 11, I'm at negative 41. And then I go up 11 and I'm up to negative 30. And then I go up to negative 19 and so on and so forth, right? And then, of course, positive 3, dot, dot, dot. So if someone asked me for any one of those terms, I could say, well, I've got it for you right there. But again, the question becomes, what happens if someone wants me to find a sub 2,398? In other words, if you were to continue this sequence on for 2,398 of those red numbers, can we predict what it will be? Of course we can. Can we do it without counting all the way up? What a stupid lesson this would be if you walked away from it thinking I just have to keep hitting plus 11 on my calculator that many times. Like that's a fail for all of us there. So what is the mathematics going to look like? Like how am I going to type this into my calculator today? No.
Oh, 2,000.
Good. Remember, if you move 2,398 times, you actually get to the 2,399th term. And that's not what we want. So I'm going to type that in along with you. So I'm going to do yeah, I got 26315. So if you were very patient and had all day and could actually count out to the 2,398th term of this sequence, yes, it would be 26,315. Everybody got that? Any questions about that? Where it's going to get a little bit harder, and I've elected purposely to not have this included today, is I'm going to give you some different sort of creative some more creative scenarios where I don't give you the first term, hence my Google search earlier. I'm going to give you the part of the recursive formula and give you some random term like the 84th term is this, and then I'm going to ask you for like the 23rd term. Got it? It's not bad. Good. Okay. I'm gonna pause this, maybe stop it, but then I gotta print some things and then I'll get with you. So if we were to, by the way, pay attention to the directions. It says name the first 5 terms and then also name the term listed in the problem. So like if this were a quiz question, I would have to do this in pieces. So that's kind of why I kept doing that with you when I was doing examples. So the first thing I'm going to do is show that I understand the sequence well enough to write the first 5 terms. So like problem 1, we all agree that the sequence starts at 31, right? So we're going to write out 31. Now, this is important. What is the behavior of this sequence? I agree. So if we take 31 and subtract 200 from it, we get negative, of course, 169. That's how that works. And then if we keep taking away 200, like you could probably do this one. If we're down 169, go down 200 more, what do we get to? If you already owe the bank 169 bucks, but then you borrow 200 more, how much do you owe? Right. And then take away another 200, how much do you owe them now? And then according to the directions, we have to do one. It says to find the first bucket. So go one more time down by 200 and where?
Negative 700.
Nice. Okay, so there's step 1 is we named the first 5 terms of the sequence. And now the next thing we have to do is name the term that's asked for in the problem. And in this case, the term that's asked for is right here. It's the 128th term. Now, again, your options are to go and write out the first 128, but that, of course, would be really weird. So let's talk about just the general vibe of how this works. You have to say to yourself, okay, if I need to get to the 128th platform, I'm going to start on the first platform. And how many times am I going to jump? To the 128th platform. So if there's like There's a bunch of platforms, and every platform is a different term sequence. So I start right here on the first platform. How many times do I have to jump to get up to the 128th?
Just
Well, if I jump once, then I only get to the second platform. Then if I jump again twice, I'm now at the third platform. If I jump 3 times, 1, 2, 3, I'm now at the fourth platform. How many jumps do I have to make to get to the 128th spot?
oh, I get it now.
Well, no, it's okay if you don't. I just want to know, like, how many jumps do you have to go to get to the 128th position? That is correct.
Bye-bye.
It's okay. So the way the calculator part of this is going to go is we're just going to type in, okay, here's the logic. What I start with plus all the change that results from all my jumps will tell me where I'm going to be. So I'm going to take the number that I start with, which is 31, and I'm going to add. And if it helps you, always just, I know sometimes you get confused by things like this, just put 2 sets of parentheses there every time. And then you can always remember, because I want you to get an A on this quiz, you can always remember to put in one of the blanks parentheses, put the number of jumps you have to make. And in the other parentheses, put the size of each jump, the effect of each jump. You with me? So again, how many jumps to get to 128? So I'm going to do 127 jumps. And what is the value of each jump? 31. Right. 31 has nothing to do with the moving of the sequence. He's just where we start. He means nothing. Once you type it into a calculator, that is your answer. And when you're done, let me know what you got, and I'll tell you if I agree with you. Unless I messed up, then well, that would be bad. Not a lot. I'm rocking it today. Solid. In fact, I think most of the mistakes I made today were not publicly available, reviewable. They were work I was doing on my own that I was going to post to Canvas, but I made 2 errors and I caught them both before I sent it. Negative 25,369. You got it. Again, that's pretty cool stuff. That means if we actually did write out all 128 of the first terms, that when we got to the very end of that, we would have that number. It's pretty cool. All right, I want you to try number 2. Okay. Without my assistance, but I would help you if that comes. So I need you to understand that when you see that language, A with the little 1 underneath it, A sub 1, that is universal math speak for the first term. The little number down here is how far into the sequence we have to go. So A sub 1 is recognized as the number 1 or first term in the sequence, okay? Mm-hmm. So in your problem, yeah, the sequence starts at negative. So if I were to start writing the sequence, and I'll try to be consistent with my colors. So when I write in red, I'm actually going to write the sequence now. So the sequence starts at negative 17. But I'm going to put some blanks here because my teacher asked me on this worksheet to list the first 5 terms. And I've only listed 1 right now. That's not a very good start, but it's a start. The other portion of this is I now need to know, like, there's every sequence has 2 critical components. Where do you start and how do you behave? Can you tell from looking at problem 2 how the sequence, it's not on the board, you have to look at your paper. How does the sequence behave? Can you tell? Somewhere on problem 2, it's telling you that to go from one term to the next, you have to do this.
What number are we looking at?
I thought we were doing problem 2.
No, I mean, like, yeah, but what?
Well, I mean, I could just point to it and tell you it's in the top row, and then you would figure out that it's -8. But
No.
the point is the language of it. So here's another little itty bitty lesson. If I put this, I want you to, if you're taking notes, I want you to write this down. This means I'll be right with you. This is confusing, and this is one of these things that I teach, and I just try to be as patient as I can because I know how absolutely hard it is to crack the code of the language. A sub n just means some term. It could be the 54th term, it could be the 68th term, it could be the 150th term. But what I need you to understand is that whatever n is, I need you to buy this part, because without this, then this is a losing battle. Whatever n is, do you agree that n minus 1 is the number that comes right before it?
Yeah.
If n is 50, what's 50 minus 1? So the 50th term is just the 49th term with, ready for it? With 8 taken away from it. That's how a sequence works, is I just tell you how does it behave. And all that up there, that writing in white and yellow and red, all it's telling you is that any term is equal to the term that came before it minus 8. So just think, if I told you, if I just put some random term up and I just right in the middle of the sequence, if I just went and put like the 100th term and I said it was like 54, you'd be like, oh, the term that came right before it was like 8 less than that. I think I'm saying that wrong, like 8 more than that. So like the sequence.
So if I'm in this right, those supposed to go -8 in that term.
Yes. Oh, you can. So I don't know what I'm trying to say, but I'm just trying to say that all this is describing to you in plain English is that any term can be found by taking the term that came before it. That's all a sub n minus 1 means, is the term that came before n. The term before minus 8. Got it? So if you and I were to continue on, if I said to you, so let's keep writing the terms of this sequence. What is the next number in the sequence? Yeah, it's just literally following orders. The sequence says go down by 8. Go down by 8 more. Go down by 8 again. Keep going. Go down by 8 again. Now, notice in the directions how the first thing it says, as far as when we start thinking about what do you want me to do, the first order comes in the form of this. Find the first 5 terms. Well, I think I can pretty much put a box around this and say, there you go. I got your first 5 terms for you. They're right there. Because that's just us understanding where to start and what to do. Start here, -8, -8, -8, -8. And you could do that a million times, and you would just keep finding the next terms in the sequence, right? Now comes the next part. We have to find the, what does that say? The 20th term? Is that what that is? Is that a 20?
Yeah.
So if we're going to find the 20th term, so that's the first platform. What we want to get to is we want to go all the way out to the 20th platform. So my question to you is if we want to go to the 20th platform, it's like a video game. How many little, so there's one hop, there's two, there's three, there's four. How many little hops do I have to make to get to the 20th platform? Okay, let's start smaller. How many hops does it take to get to the second platform?
8. Negative.
No, forget the negative. I'm asking you literally. You're like a little frog here. Ready? Here goes the frog. He's going to jump from here, ribbit, all the way to here. That's forget the number 8, -8. All that. How many times did I have to jump the little froggy to get to the second place? So to get to the second platform, we had to jump one time. How many little froggy jumps will I have to make to get to the third platform? 2, because now the froggy resets and I go, there's hoppity hop, hoppity hop. And look, I'm now on the third platform. I'm on a sub 3. So to get to the platform number 3, I have to jump twice. How many jumps does it take to get to the fourth?
3.
Good. Now I don't have to keep writing these because you understand like the number of steps you take is not the same as your destination. Like if I start on the number 1 and I walk forward 10 steps, I'm not on 10, I'm on 11, right? So if I want to get to the 20th platform, how many hoppity hops do I have to go to get to the 20th level?
19.
Yes, it takes 19 jumps to get to the 20th level. It will always take one less than where you want to get to. If you wanted to get to the 500th platform, you'd have to jump 499 times.
Okay.
The fact that you start on level 1 can be confusing. Like a sub 1 is like the first term. It's like, here I am, first term. If I jump once, I'm not on 1, I'm on 2. If I jump twice, I'm on 3. It's always, see how they're one away from each other?
Mm-hmm.
So when we think about this sequence, we have to think about it as where do I start and then how many jumps do I make? So let's talk about this sequence. Where do we start? What's our initial value? Like where does the sequence begin? So I have -17. Now I'm going to add 2 things together. This 2 sets of parentheses is going to contain 2 things. Number 1 is how many jumps do we have to go? Right. And then number 2 is what's the value of each jump? Like every time I jump, how is the sequence changing? When little froggy goes boom, boom, it's every jump is worth -8. So I just type that into my calculator and I'll know what the 20th term is. Presto. Alakazam. I have no idea what the answer is. Trust you. Check it.
That's last time I tried telling you something.
Just saying. But I got also that -169. So again, let's translate that into something that should make sense. Look at those red numbers on the TV. It means if we continued writing red numbers like that and we went out, because we only have 5, if we did the 6, 7, 8, 9, 10, if we went all the way to the 20th one, the 20th one would be -169. Number of jumps, value of each jump. Let's do another one. So on problem number 3, where does the sequence start? So I'm going to write that down. Then I'm going to put a comma. Now, every time I go from one term to the next, how is the sequence changing? It's going down by 10. Very good. So if I start at down 3, -3, and I go down 10, where's the next term?
-7.
No, it starts at -3, not 3. Try again.
Okay. You got that one?
Yeah, and you shouldn't be using a calculator for these because we're just adding 1 to the tens place every time. Like if you're 13 feet underwater and go 10 more, you're 23 feet underwater. And then you're 33 feet underwater. Then you're 43 feet underwater. So on. So the problem asks us to find the first 5 terms, so we can say, done, thank you. Now comes the question. Where do we start?
So I'm gonna figure out how many jumps it takes.
Right. So the structure of it for you is where I start plus a multiplication problem. You just set it up like this every time. Where do I start? Plus all this stuff. Now, how many jumps do we have to make to get to the, what does that say, 34th place? How many jumps do you have to do to get to the 34th platform?
Well, 34 would be in between.
How many times do you have to step forward to go from space 1 to space 34?
4. Oh. So we would only need 33 of them.
To get to the 34th
So
platform?
this number for find A just has to go down.
Yes.
Okay.
Whatever position you want to get to, just take 1 away from that, and that's how many moves. That's it. Now the other number is, what is the sequence doing each time? How does each term become the guy after it? Okay, here, look up at the TV. How did this become this?
Oh, you subtracted by 10.
How did this become this?
Subtracted by 10.
So when I ask you, like, what's happening each time, every time you do a step, you're taking away 10. We just have to do 33 of those steps, which is, that's what calculators. So before you type it in, put it on your paper. We started at -3. The number of jumps is 33. And the value of each jump is -10. If you follow this format, these words right here, if you want to write something down, it should probably be this. That is your template for how to do everything. Where do I start? Plus how many jumps times the value of each jump. Then you just type that happy little thing in your calculator. It's going to be -3, -363 or something like that. Did you get it? Oh yeah, of course. 10 times 33 is 330 plus 3 is 3. It's -333.